Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well and you are ready for today's program. Because today on the show we have, you guessed it, Ralph Bond. He joins us every single Friday to talk about science and technology trends and what that exactly means. Well, we'll get into that in just a moment. But before that, computeramerica.com. That's where you'll find everything, including past shows, future shows, show notes, articles, all that and more. Anything that we do here at Computer America, you can find on our website. And of course, you'll find links to social media. You'll find links to the podcast and all the distribution services that you can find us on. And ladies and gentlemen, anywhere on social media at Computer America, I think we were able to snatch them all up. Give us a like, give us a follow, and check us out there. So with that being said, though, computeramerica.com is going to be the best place for today's show in particular because we have the show notes, and you can go to the Ralph Bond section at the top, find today's program, and you can, of course, find the show notes that will have links, articles, pictures, even more information, and, of course, sources if you want to double check to make sure Ralph's not just making this stuff up. I have to do it myself, but because I can't believe sometimes how insane these stories are. So there you go. Now, with that being said, let's go ahead, bring Ralph on, and just have fun with it. So, once again, he is our science and tech trends correspondent. Ralph, welcome back onto the program. How you been?
I'm great. And by the way, yeah, some of these stories are hard to believe. But friends, I'm telling you, what we do is not science fiction, but science hope in a way. So what Ben and I do each Friday, especially if you're listening to us as a podcast, this is important. What we do each Friday is highlight 4 recent articles that show us key trends and developments in a host of things: artificial intelligence, of course, robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, construction tech, space research, physics, you name it. But most important of all, this is key, we're going to give you an oasis of positive news to end your week, thanks to the world of science and technology.
Absolutely. And I think, just browsing the headlines myself before the show, you have brought us a very high-tech kind of show today. So we're going to go ahead and start with number 1. And, I don't often give, shout outs and kudos to other people in the tech space, and especially the tech entertainment space. Although, Ralph, I will say one person that I love his videos and love what he does. Have you ever heard of the gentleman named Jerry Rig Everything? Or he runs a channel called Jerry Rig Everything.
Oh, I'll have to check it out.
You should. He does an amazing job where he takes pretty much every recent technology gadget, phone, foldable phone, the new Nintendo handheld devices, any consumer electronic you can imagine, and he puts it through his battery of tests where he scratches, scrapes, knocks, drops, burns. It is a real good methodical way that he kind of breaks down and shows just what happens when even the most minor of damages can happen to today's electronics. It's these things are fairly fragile. Let's just put it that way. So reusability, repairability, all very important. But what about, maybe something that can self-repair? And that's something that we haven't seen before. And that would be so helpful. So story number 1.
Oh, yeah. Yeah, story number 1. By the way, put a link into that resource on today's show notes, because that's a fun little aside that I think I want to check that out too. So let's get into the first story. It comes from livescience.com. Headline: unlike conventional electronics, new liquid metal-infused circuit boards can self-heal and work after taking heavy damage. Now, the implications of that are profound. I mean, it's really amazing. Okay, so let's get into this. Researchers at Virginia Tech have developed a new type of circuit board that can self-heal, reshape, and remain functional even after significant damage. Whoa, let that sink in. Think about the possibilities here. And let's kind of start going through a rundown of the core of this innovation. So first is the key materials. So Vitrimer, that's Vitrimer, plus liquid metal is kind of the core ingredient mix here. And Vitrimer, I said, what the heck is that? It's a polymer that's rigid at room temperature, but becomes malleable when heated. And then the other part of the equation, liquid metal droplets. They provide connectivity and enable self-repair by reconnecting broken pathways. Friends, I need to stop and explain. What we do is just give you highlights from these articles. There's so much more information. That's why the show notes that Ben mentioned are so important. Come out to computeramerica.com, get the show notes, get the links, dive deeper if you wish, because we're just going to give you the kind of highlights here, skipping a stone across the deep ocean of these stories. So the capabilities of this technology, these boards can self-heal. Damage like cuts or deformation can be reversed with heat, just with heat. And the boards can be reshaped and reused multiple times. And the board's materials can be reclaimed without harsh chemicals, unlike traditional thermoset-based boards. A couple weeks back, we talked about thermoset, which is extremely difficult to recycle. And you find thermoset plastics in your automobiles and other sources. So most circuit boards, a little side note here, most circuit boards are made using thermoset plastics, particularly in the form of epoxy resins. And they're extraordinarily rigid. They're difficult, almost impossible to recycle. So what we're talking about here is a technology that's very recyclable friendly. So let's go on here to the story. Here are a few performance highlights of the new circuit board technology Virginia Tech has come up with. Doubled strain tolerance compared to using just Vitrimer alone as an ingredient. Maintained conductivity after repeated damage repair cycles. And withstood temperatures up to 200 degrees Celsius, that's 392 degrees Fahrenheit, during testing. Pretty really tolerant.
Yeah, really opens up to a lot of different fields. Like, maybe not, actually lava, but, everything short of that, that's a lot. It's a lot of fields that it could definitely be in.
Yeah, yes, the environments that it could be in and the ability to self-heal is pretty astonishing. And how this new Virginia technology will help the environment. It tackles the growing e-waste crisis. I think we're all very aware of this. Electronic waste has doubled in 12 years to 62 billion kilograms. Traditional boards, circuit boards, are hard to recycle, as we've mentioned before, due to permanent thermoset plastics. And this new composite offers what, I love this phrase, a circular economy alternative. That means you create the product, it does its job, but it can be recycled, come back again and again and again. That's what they mean by circular economy alternative. Cool stuff. Again, get the show notes because there's so much more to tell you if you go and look at the article and the resources.
Right, and even the and even the paper that you link to as well, you can kind of see it being deformed and then through heat being reformed back to its original. And they're doing this with like LEDs to show that even by one of my favorite pictures here was this one. They punch a hole right through the wire that would be there, and then the LED still works because it's able to repair itself. Very, very
amazing.
Cool. Yeah, technology. And again, maybe not Terminator style repairing itself of technology, but hey, it's a first baby step and maybe something that makes things a little bit more resistant to damage. So very cool. Story number 1. Story number 2. Let's go ahead and talk about data centers, everyone's favorite. It's all over the news. If you want to talk about a hot button issue, Ralph, I think data centers are today's issue, tomorrow's issue, and I think will always be an issue until we come up with a better way to do them. So story number 2, very relevant.
Yeah, extremely relevant. So this comes from techradar.com. Headline: Cooling data centers is a multi-billion-dollar problem. Subhead: Now researchers want to use a common cooling mechanism found in animals to solve it. Another example of a story where science is taking its cue from nature. This is really cool. And for me personally, this is a very important story because I live in Hillsboro, Oregon. Look it up on the map. We're an outlying area from Portland, Oregon. We're the home for a huge amount of the R&D for poor old Intel. They've been struggling, but nonetheless, there's a ton of research and buildings and all kinds of stuff going on in Hillsboro, Oregon. But now we used to be called the Silicon Forest. I think pretty soon we're going to be called the Silicon Data Center of the nation, because right here in little old Hillsboro, we have already 15 big data centers with 10 more in the works. What? And so energy consumption and other issues that these data centers introduce into what had used to be farmland here is a big problem. So this story really resonated for me, and I want you to check it out. We have a link to the research paper too for this. So again, cooling centers, multi-billion-dollar problem. And these researchers want to use a common cooling mechanism found in animals to solve it. So let's dive into this. As AI and cloud computing grow, the rising demand for data processing is driving up heat output, with cooling already making up nearly 40% of a data center's energy use and projected to more than double worldwide by 2030. Wow. Ooh. So researchers at the University of California, San Diego have developed a new cooling technology that mimics the way animals regulate body temperature. Good old sweating.
I can imagine making, although making computers sweat, not the easiest thing. And also I will say from the from the outset, I'm like, moisture and computer parts, not something you generally want to associate, but let's find out.
Yeah. So what they've come up with is a passive system removes heat from electronics using evaporation, offering a potential alternative to traditional cooling methods in data centers and other high-powered computing environments. The core of the system they've come up with is a fiber membrane with a network of tiny interconnected pores that use capillary action to draw cooling liquid across the surface of the equipment. As the liquid evaporates, it efficiently removes heat without requiring extra energy. It's kind of a passive thing. And in the show notes, we have some more details from the University of California, San Diego team's research paper, which we have a link to in the show notes as well. So I will go through this real quick. Capillary-driven thin film evaporation in nanoporous membranes has emerged as a promising thermal management strategy for high-power electronic devices, owing to its theoretical critical heat flux. This is very geeky, enabled by extensive evaporating areas within the nanopores. The research involved fiber membranes with three-dimensional interconnected open pores as efficient evaporators. Moreover, the fiber membranes demonstrated long-term stability. And finally, these findings, as the researchers note in their paper, suggest that 3D fiber membrane evaporators are highly promising for advanced thermal management, offering efficient, stable cooling solutions to meet the demands of modern electronic systems, most notably data centers. So, wow, cool stuff.
Absolutely. It even reminds me of one, actually found it. It's from 2020. Let's see, September 2020. And Ralph, I don't know if you remember this, but Microsoft actually put a data center in the ocean. Like they put it in a watertight capsule, and then they submerged it in water, and then of course it cooled using radiant cooling from that. So this is bringing cooling a little bit, the water a little bit closer to the chip to make it cool. But there are solutions that a lot of companies are looking at, be it making your computer sweat, be it submerging them in water in the ocean. There has to be a solution for this, Ralph, because what's happening right now is like, it's the best or I should say probably the most economical way that we have, which is build these giant data centers, but it's not the end game. It's not the end result of these data centers. So we'll see what technology kind of wins out.
Yeah.
Yep.
Or been a combination of multiple technologies. This could be used in conjunction with other traditional cooling technologies currently involved to help reduce the demand on those conventional cooling systems. So there's all kinds of things like that. Also in the area of refrigeration and cooling, there was a recent development. I think it was Samsung in conjunction with an American university coming up with magnetic cooling to replace traditional refrigerants. So there's a lot of interesting stuff going on in the world of cool things down, please.
Technology is going to cause so many problems, but hopefully technology will also solve most of those problems. So there you go. Story number 2. Story number 3. Let's go ahead. And like I said, it's going to be a very high-tech kind of show today. And electronic ink is something that we've, kind of touched on here and there. And there's even, ladies and gentlemen, if you're looking for a nice little gift for the little scientists in your life, I think there's even like electronic ink pen sets that kind of teach kids how to, kind of like light up LEDs, and they can draw with the pen and, kind of run currency through it. It's a fun thing for kids, but this seems a little bit more applicable to a larger industry for story number 3.
Right. So story number 1, again, was about self-healing circuit boards. In a way, this is kind of thematically a kindred spirit. The headline here is Scientists Invent Weird, Shape-Shifting Electronic Ink that could give rise to a new generation of flexible gadgets. This comes from livescience.com. And by the way, a huge trend in this world is flexible, making all kinds of electronics flexible, shape conforming, and so forth. And that's a big, big trend. And this fits very nicely into that world. So scientists at Korea Advanced Institute of Science and Technology and Seoul National University, so this is South Korea, of course, have developed a novel electronic ink that enables circuits to switch between rigid and soft states simply by heating. That's like our circuit boards in story 1, that heat would repair them, right? This innovation could revolutionize flexible electronics, including wearable health devices, brain implants, and adaptable robotics. Okay. So now we'll get into some of the key features of this electronic ink. First, let's talk about the key ingredients. Gallium, a metal that melts just below body temperature, combined with a polymer called dimethyl sulfoxide solvent. So that's the combination. That's the key ingredients. How does it work? Heating breaks down the solvent, creating an acidic environment that removes gallium's oxide layer, allowing particles to merge and form conductive paths. Ben warned you, this is a geek out show today. This is very geeky stuff. So it also offers precision capabilities. You can print features as small as 50 micrometers, thinner than a human hair, and the stiffness and flexibility control properties are amazing. The material becomes up to 1,400 times softer when warmed. Wow.
Sounds like it'd be very malleable and usable in a lot of ways. So nice.
Yeah, exactly. And how this technology might be used? Well, for wearable health monitoring, rigid at room temperature, softens on skin contact for comfort. Let that sink in. That's pretty interesting. They mentioned a moment ago brain implants. Well, stiff. This could create technology that's stiff during surgery for accurate placement, but softens inside the brain to reduce irritation. Okay. And the practical manufacturing potential is good here too. It's compatible with screen printing and dip coating that already exists in our factories around the world, making it a viable for large-scale or 3D printed electronics. And finally, the research tackles long-standing challenges in liquid metal printing and opens doors to electronics that adapt to their environment and usage. Wow, so cool.
The idea of thinking that robots, and not just robots in the future, but even just computers, are these rigid things that can't be bent, they can't be deformed, they rigid. That is quickly going away. So
exactly.
And also, ladies and gentlemen, if you're watching the video portion, sometimes, Ralph goes out, does the research, finds the sources, does all this amazing work. And then sometimes I throw up stupid little videos that you can see as well. So this is what I was talking about way at the beginning of the show. And
Fun.
kind of like this, but of course, what Ralph, what the story has been talking about is more of a manufacturing setting, something that is going to be much more precise. This is what I was talking about with the kids, Ralph. And this
cool.
is, you're able to write just like a ink pen, and you're able to, create this thing to actually draw with ink, and the ink itself is conductive. I'm sure similar principles, but of course this one is much more precise and better. So there you go.
So great.
It's a lot of cool things are going to happen with circuit boards that can be printed in place and put in environments that they traditionally could not. And hey, like you said, brain implants for one would be an amazing one. So
yeah.
Yep. Story number 3. Story number 4. Let's go ahead and hop on down to this last one, because, ladies and gentlemen, if you are unable to hop because you're like, my knees, I'm not that young anymore, I can't hop. Well, maybe this one's for you.
Yeah. This is a really great and inspiring story for the world of prosthetics. And it comes from good old MIT, their newsroom, which is just an endless treasure trove of fabulous stories. And this is a good example of what we do for the last story of every show. Usually it is something in medical science technology. And the headline here is a bionic knee, here's the key, integrated into tissue that can restore natural movement. This is a part of a trend, Ben, we're seeing where the technology is interconnected with the patient's biology. Think about brain implants and other things of this nature. This is kind of in the world of prosthetics in this case. And there's I
was going to say, even 10, 15 years ago, before the technology kind of caught up with us, I guess prosthetics really really wasn't much better than like peg legs, back in the day. Like, they had joints and they could do that kind of thing.
Sure.
But this is taking it, to almost lifelike. It's very, very cool.
Yeah, it's the whole trend of integrating these prosthetics with the human tissue, whether it's brain, in this case, knee tissue, and so forth. So their research paper title really gets it. Tissue integrated bionic knee restores versatile leg movement after amputation. So we're talking about people who are amputees from the knee down. So let's get into this story. I love it. I just think it's so great. So my comment, this is a great example of the trend for integrating prosthetics directly into the human body, as I mentioned before, linking to tissues and, as a result, brain controlled. So MIT researchers have developed a new bionic knee that can help people with above-the-knee amputations, help them walk faster, climb stairs, and avoid obstacles more easily than they could with traditional prosthetics. Unlike prostheses, in which the residual limb sits within a socket, your peg leg comparison, the new system is directly integrated with the user's muscle and bone tissue. Now, how they do this is a whole story in itself. Again, friends, we're just giving you highlights.
Yeah, the picture that MIT actually included, I think it's actually the first one, and you can see here where they have, it almost looks like, I don't know, some kind of band, but that's actually the muscle tissue and fibers. Right. And they do what looks to be very complicated surgery to kind of, implant all this. But suffice to say, these wires probably have something to do with the control. So that's as far as I know. Yeah, find out more information in the article.
Yeah, again, a good example of please come out to get the articles, because we're just going to give you the bare bone highlights. And this enables greater stability and gives users much more control over the movement of their prosthesis, needless to say. Participants in a small clinical study that MIT conducted also reported that the limb felt more like a part of their own body. That's the key, compared to people who had more traditional above-the-knee amputations. Now, Hugh Herr, H-E-R-R, Hugh Herr, a professor of media arts and sciences at MIT, noted, quote, a prosthesis that's tissue integrated, anchored to the bone and directly controlled by the nervous system, is not merely a lifeless separate device like your peg leg, but rather a system that is carefully integrated into human physiology, offering a greater level of prosthetic embodiment. This is not simply a tool that the human employs, but rather an integral part of self. Wow. Please come out and check out the research paper, because as Ben was showing you with the illustrations here, you can learn so much more about this wonderful and very inspiring and very hopeful and uplifting way to end the show today.
Yeah, no, you can imagine that if you are someone who, doesn't have a leg anymore, having a prosthesis that, when you want to bend your knee or you want to step and, point your toe or something, and your prosthesis does exactly what your brain is telling it to do. Yeah, that's not just a prosthesis. That is your foot. That is your leg. And I'm sure that's what she's talking about. It's, it becomes part of you. It's not just, your tool. It is your leg. So
yeah.
A lot of hopeful and, advancements. Of course, foot today, maybe arm and hand tomorrow. And hey, a lot of people are going to have a much better quality of life with these advancements. So good job, MIT. I know it's just simple, small research, like you were saying at the beginning, but hey, it's a first, dare I say, step to further research. So there you go.
Yeah.
That's our 4 stories. If everyone out there has been keeping count, I know counting to 4 sometimes trips me up as well. But you may notice in the show notes, there's even more. There's more stories, and these are honorable mentions. As I usually say, these are stories that are not less, they're not worse. They just, it's just, hey, we try to keep the show in a more condensed format. And these honorable mentions are stories that you should definitely have your focus on, have your attention on, but we just don't have time for it here in the show today. So Ralph is going to give you the headlines. He's going to give you some sources. And if you want to find out more, come on out to computeramerica.com, go to the bottom of the show notes, and you can find everything right there in one place. So with that, Ralph, let's go ahead and give them the headlines.
You got it. And this is the first of 4 honorable mentions this week. This comes from Engineering at Meta. Headline: using AI to make lower carbon, faster curing concrete. A good example of a trend story in the world of construction technology, which once again, I always say, don't think construction or agriculture is boring. It is not. There's so much wonderful technology. This is a great story in that category. The next one comes from medicine.net. Headline: a mild spinal zap can cut brain-computer interface learning time in half. That's the whole world of the brain-computer interface is such a big field right now. And what they're saying is a little zap can help you learn half the time it normally takes.
Yeah. I so they said spinal zap. So, an electrical current, not a spinal tap. So
right.
Everyone out there who's wincing, zap.
Spinal zap, Z-A-P. That's a good one. Also makes me think of the rock group Spinal Tap. Anyway, okay. Next one from livescience.com. Headline: scientists invent photosynthetic living material that sucks CO2 out of the atmosphere. Wow. This also has implications for the construction industry and many other fields as well. Very geeky, very interesting. Check it out. And the last honorable mention, University of California, San Diego is the source. Alzheimer's gene therapy shows promise in preserving cognitive function. And so much research, so much work, especially in the area of gene therapy, is aimed now at dealing with Alzheimer's, which of course is just a horrific problem.
It is. And for everyone out there who's out there, it says preserving, not increasing. So you have to have it in the first place to be able to keep it. So, remind that out there for people like me.
Point.
Yes, it will not help those who have limited availability. It's preserving what you got. So there you go.
There you go.
So with that being said, ladies and gentlemen, the music means... There's the music. Music means that we are wrapping up the show today. Ralph, I want to thank you so much for putting this all together, as always. Great stories, great show. And ladies and gentlemen, if you want more, ComputerAmerica.com will have all of Ralph's past show right there in his little nook of our website, and you can find all the past show notes that have links, articles, videos, everything. And of course, we'll include everything that we talked about here on the show today in the show notes. So until next time, have a great weekend, do something fun. We will catch you here next time. Ralph joins us every single Friday as our science and tech trends correspondent. And until then, have a great day. Thank you so much. Bye, everyone.